here's some more examples of finding the general antiderivative. So, sine x, right? The derivative of sine is cosine, but the derivative of cosine is negative sine, right? So, if I'm looking for the function whose derivative is sine, if I do cosine, I'm going to be off by a negative, right? Because the derivative of cosine is negative sine. So I got to throw in that negative so that when I take the derivative, right? And I'm going to put my plus c. Since the derivative is negative of negative sine x, which is sine x. So that's one nice thing about taking antiderivatives is you can always check. You can always check by taking the derivative of what you've got. Make sure that you get back what you expect. Okay? Remember that? What about this one? This one shouldn't be too hard to think about, right? Remember we had the example of x squared, which went to x cubed over 3. We also did x to the 4th, I think, which went to x to 5 over 5. What is going to be is you're going to get x to the n plus 1 over n plus 1. Okay, sort of by inspection and guessing, let's check this. What I have is 1 over n plus 1. And then when I'm taking the derivative of x to the n plus 1, I'm going to get n plus 1 x to the n, right? So these cancel out, and I have x to the n. So exactly what I expect. So this is actually really important. We can use this. In fact, I need to use this for part of my next two examples. So once I have this, is sort of like the opposite of the power rule. So let me put that up here so we remember it, because I might have to erase this so I have more space. If well, x to the n plus 1 over n plus 1. It is on your sheet of antiderivatives, probably the first one, right? But of course, n is not equal to negative 1, because if n was equal to negative 1, we'd have 1 over x, right? And 1 over x is special because it's natural log. Okay? Now, notice this one is precisely this kind of thing, right? So I can write this as 2/5 times 1 over x minus 3 times x to the minus 2. Okay? So the constant doesn't make a difference when I'm doing derivative or antiderivative. I pull it out in the front, right? So if I'm going to look for the antiderivative, I'm going to look for the function whose derivative is 2/5 times 1 over x. The 2/5 just goes along for the ride. And I know that the antiderivative of 1 over x is natural log of absolute value of x. Now what about this one? This one, I'm exactly of this form. So I can just use this form, right? This would be x to the minus 1 over minus 1, right? Because n is negative 2. So this one cancels that. So if I can write, forgot my plus c. So if I just clean this up a little, plus 3 over x plus c. You can also do this in your head, right? Because you're going backwards. It is kind of confusing at first because you were so used to power rule doing n minus 1, and now we're doing n plus 1 because we're going the other direction, right? So that makes sense, but then when you're working fast, it's kind of easy to like screw it up, right? Because we're looking at the antiderivative, we're going plus 1, especially when you're like negative, right? Because negative 2 plus 1 then becomes negative 1, and you're so used to like, you know, negative 2 goes negative 3, whatever. So just keep in mind which direction you're going, okay? Now this last one, It's a little bit different, right? And I should actually, well, I'll get rid of this. Yeah, we'll just get rid of it. Whatever. This last one, we'll just write it up here. But I'm gonna rewrite it. And then this would be x to the 4/5. Right? So, first of all, this thing. This probably doesn't look very vaguely familiar. Actually, it should look vaguely familiar because even last week we were using this, right? The derivative of inverse tan is this 1 over 1 plus x squared. Okay? So we did one with that last week. There were inverse tans all over the place in the last week worksheet, right? So we know that the antiderivative then, this is just going to be inverse tan of x. Okay? It would be different if it was 1 over x squared, right? Because that would just be a power. But this has got the 1 plus x squared, so we know it's something special. Now this guy, I can just go ahead and use this power rule. So I've got 4/5 plus 1 over 4/5 plus 1. So let me clean that up. 9/5, right? So it's going to be 5/9 x to the 9/5. Okay? Instead of, right, so if we took the derivative, we're going down, it would be x to the minus 1/5. Now we're taking the antiderivative, so we're going up.